Good morning, class. We are looking at the final exam review, which covers from the beginning. It's a cumulative exam from section 1.6 all the way to 5.2. First, as you can see, there are many differentiation formulas from the definition to basics to the product rule, quotient rule, chain rule, so on and so forth. Delta y versus dy, by definition, delta y is f of x plus delta x minus f of x, and dy is f prime of x dx. And if you pick a point and draw a tangent line and calculate that, that linearization refers to finding the tangent line. Then we have a lot of logarithmic properties that come from this simple definition. When, of course, the base is positive and can't be 1, you go with the arrow b to the power of y equals x, and it gives rise to these definitions. We've seen it several times. If you're dealing with a common log, that means the base is 10, you don't write it, you put log, and we can see the transition from general logs to common logs. And in the case of a natural log, we use ln, that means the base is e, and again, those formulas. Exponentials and logs or inverse functions make symmetric with respect to the line y equals. This is the change of base formula. And when you want to take the derivative, you basically flip it over. By the chain rule, you multiply by its derivative. If the base is not e, you have to tag along 1 over ln b by the chain rule, by the change of base formula. Integration formulas, they are all reverse process of differentiation, so we should be very comfortable with those. And then we add the FTC, which says the derivative of the integral is the function itself, and the integral of a to b f of x dx is capital F of b minus f of a, which is called a definite integral. It's a number. And the substitution rule, which is the reverse process of the chain rule. So that's the synopsis of the formulas that you're supposed to know. Let's start differentiating. And we change this to x squared plus 3 to the power of 1/2. We bring it back. And the reason we do that, to get it ready for the extended power. So 4 times negative 1/2 times the same thing to the same power, subtract 1 makes it minus 3/2. By the chain rule, g prime of x, the derivative of the inside is 2x. This goes down, takes the positive 3/2 as the exponent. This 3, their product is negative 4x. They remain in the numerator. If you want to change it to a root format, you can. This also uses the extended power rule, everybody. First, in conjunction with a quotient rule. So first 5, and then 2x plus 3 over x minus 8 to the power of 4. And then we call this f, we call this g, and we follow f prime g minus g prime f over g squared. So the top gives us a 2 times x minus 8. The bottom gives us 1 times the top, and the bottom squared. And that's the final answer as far as the calculus is concerned. Now we are going to simplify. This is 2x minus 16. This is minus 2x minus 3. These two cancel each other. We get negative 19. This one, we write it. This one, we write it 2x plus 3 to the power of 4 over x minus 8 to the power of 4. This is negative 19. The bottom remains. The reason we are changing it in this format, mainly for the denominator, we recognize x minus 8 has exponent 4. With 2, they add up. And the numerator is the product of those 3. We get negative 95 times 2x plus 3 to the power of 4 over x minus 8 to the power of 6. Implicit differentiation, we recognize this as a product rule for x squared times y. We put a raised dot in between, and we call this f times g. And we use the product rule on that. F prime is 8x times g, which is y, plus g prime. Now, y, the derivative is y prime or dy dx times 4x squared. Now, 2y squared is like 2 times g of x to the power of 2, or you can write ny to the power of n minus 1 y prime. That gives you 4y y prime. Any number results in 0. Since we are solving for y prime, we keep these two together by taking the y prime, or better yet, 4y prime out, factor it out, move this one to the other side. If we divide by 4 times x squared plus y, then minus 8 cancels out, the 4 becomes negative 2, and y prime is negative 2xy over x squared plus y. That is the final answer, everybody. To differentiate cosine 3t to the power of 4, as I've mentioned it before, you are going to say cosine and pause. It makes it easy to notice that the derivative is negative sign. And then any sinusoidal function requires an argument, so the same argument, and then by the chain rule, you multiply by the derivative of that. In other words, we are looking at this piece, everybody, and the answer is times 12t cubed. Put them all together, you get negative 12t cubed with the sine of 3t to the power of. A small rock is dropped into a lake. Circular ripples spread over the surface, with the radius of each circle increasing at a rate of 3/2 feet per second. Find the rate at which the area of a circle is changing when the radius is 4 feet. So first, information about the circle. In algebra / geometry, we should know from the center to the circle is the radius. From the center go both ways because the diameter. So diameter is 2 times the radius. Circumference going around it is 2 pi r. Area is pi r squared. In this question, we need the area only. So area is pi r squared. dr dt is 3/2 feet per second. We want to find dA dt at the precise moment of r being 4. This is translation of the question. Therefore, we are going to differentiate this, meaning dA dt, and pi is a number, we keep it. So in essence, you're differentiating r squared, which becomes 2r dr dt. So we're looking at 2 pi r dr dt. Replace the r with 4, dr dt with 3/2. You get 12 pi square feet per second, units of the numerator over the units of the time. Exact answer, approximation. Make sure you always answer precisely. If they ask for approximation, see how many decimals they want. You go to the next one and then make a decision accordingly. We're going to find dy dt. The moment you see dy dt, it indicates that t is the independent variable. Therefore, the derivative of x is also the x dt. So we're going to do implicit differentiation. 4 times the same thing cubed, and by the chain rule or the extended power rule, we need the derivative of the inside. This is 5 dx dt. This is dy dt minus x minus dx dt. Any number results in 0. You can solve for dy dt, but it's faster to plug in, and that's what we are going to do. 10 minus 9 is 1, 5 times 3 is 15, and so 4 times 15 is 60. And these two result in 57. We move it to the other side, becomes negative. We divide by 4, and that's the final answer. Dy dt is minus 57 over 4. A 20-foot ladder leans against a building. The base of the ladder slips away at the rate of 2 feet per minute. Find the rate of change of the height of the ladder when the base is 12 feet from the building. You have to draw the setting. So here's the building or the wall. Here's the ladder, moves this way, and it's coming down this way. the ladder, and it gives rise to this shape, a right triangle. And we know the ladder is fixed at 20 feet. Therefore, this is dx dt, and coming down dy dt is of interest to us. So we write dx dt is 2 feet per minute. This is 20 feet. Dy dt is a question mark. At what point? When the base is x is 12 feet. So we know a squared plus b squared equals c squared. Therefore, x squared plus y squared equals 20 squared. And that comes from Pythagorean theorem. All you have to do, because you wrote the written properly, you are going to differentiate with respect to t. So this is 2x dx dt, 2y dy dt, 400 results in 0 because it's a number. If you put the 12 in here, you can find the y at the moment that x is 12. Remember, this is 400. This is 144. And y is 16 feet. Plug in. 2 times 12 times 2 is 48. 2 times 16 is 32. Move the 48. Divide by 32. You get negative 3 halves. So dy dt is negative 3 halves feet per minute. And again, x is increasing, dx dt is positive, y is coming down, decreasing, therefore must be negative. How do we find limits? We just plug in. If we get a number, we are done. If we get 0 over a number other than 0 is 0 and we are done. If we get a number over 0, we have to just be careful whether it's infinity or negative infinity. But most of the time, we get to indeterminate forms of 0 over 0, infinity over infinity, infinity minus infinity, in which case we have to use our algebraic techniques to finish the job. For example, here, if we plug in, we get infinity over infinity. And anytime you have a fractional format or a rational function where x is approaching infinity, when x is approaching infinity, the technique is to divide by highest degree term in the denominator. So this is infinity over infinity. You do that, and I hope you recognize as x goes to infinity, this goes to 0, this goes to 0, and the answer is 2. However, a better course of action is always to simplify first, meaning you can factor this one into 2x over x minus 4. And the methodology is the same. Because x is approaching infinity, you divide by highest degree term in the denominator, which gives you the same answer because this goes to 0. But just wanted to make sure that you understand both methods work. Now, as we look at this case, if you plug in minus 4, you do get 0 over 0. And the technique is the factoring. We've already done the factoring. And by the way, I remind you, if you get 0 over 0, that means x is approaching negative 4. X plus 4 must be a factor of the denominator. And that's the problem. And it is, and you get rid of it. And now that you factor it, you can plug in negative 4. You get minus 8 over minus 8, which is 1. So the technique is the factoring. But over here, if you plug in, actually it works out and you get 0 over negative 16, which is 0. Over here into, if you factor it first, you get 0 minus over minus 4, which is also 0. So that doesn't make much of a difference. But ultimately, any rational expressions that can be simplified, it's ideal. And so what about this case? I hope you again see that it's better to simplify first, okay? And so we use 2x over x minus 4 in both cases. And please understand when x approaches 4 from the left or right, in essence, in both cases, we have 8 over 0. Do you see that? Now, one might say, okay, what do we mean by x approaching 4 from the left? 8 is really, 4 is a little bit less than 4, so it's like 7.99999. But from the left and right doesn't make much of a difference. However, what makes a difference when you put it in the denominator? Because 4 from the left, as an example, 3.9 minus 4 gives minus 0.9. So it's 8 over 0 from the left, which results in negative infinity. However, in this case, when you plug in, you get 4.1 minus 4, let's say, which is positive. And now the answer is positive infinity. And that's the key. Distinguish between negative and positive infinity in this manner. It's very fast to figure it out. Over here, if you just plug in and recall that a to the power minus m is 1 over a to the power of m, makes e to the power minus t 1 over e to the power of t, which makes it 1 over e to the power of infinity, which makes it 0. So the answer is 12 over 4 or 3. In this case, if you plug in infinity, you get infinity in the denominator, and the result is 0, no matter how big the numerator is. And in this case, everybody, because t is approaching negative infinity, part c is identical to part a as a result, because this one t is approaches infinity. So e to the power minus infinity becomes 0, so 12 over 4 or 3 is the answer. And finally, this one, you just plug in, because e to the power of 0 is 1, you get 12 over 7. So I think it would be really interesting to see all those side by side so you can compare and contrast. What about differentiating this expression? Bring this up, make it ready for the extended power rule. And that is, first keep the 12, then times the exponent n or negative 1, then times the same thing to the power of negative 2, and then times the derivative of the inside 3e to the power of t. As you notice, this one, and this one, the product is negative 36e to the power of t. This goes down with a positive exponent. So that's pretty straightforward, everybody. Let's move on and see what happens here. If you plug in, you get 0 over 0, and the technique is factoring because x is approaching 5. We should have a factor of x minus 5. We do. And if you plug in, you get 10 over 5, which is 2. Part B, you plug in, you get 0 over 0, and the technique is LCD. You multiply the top by 4x over 4x. The numerator becomes x plus 4. The denominator, you keep it as a product. These two cancel each other. And now if you plug in, you get negative 1 over 16. This one also 0 over 0. The technique is the conjugate, multiply by the conjugate, because the conjugate of a plus b is a minus b. Their product is a squared minus b squared. So when you multiply, this gets squared up and comes out. Minus 1 squared, which is 1. 1 and minus 1 cancel each other. H and H cancel each other. This is what we get. And if you plug in, you get 1/2. So it's very straightforward, everybody. Okay, what about this one? We are taking the limit, and if you plug in, you get infinity minus infinity. The technique is to divide, just like a rational expression, divide by highest value in the denominator, which is e to the power of t. So methodology is similar to that, everybody. And of course, since t goes to infinity, this goes to zero, this goes to zero, positive 1 over negative 3 gives you negative 1/3, everybody. All right, differentiating, notice that we are dealing with a product rule, therefore we put a raised dot in between, so it becomes clear that we need the product. And therefore, e to the power of 2x is itself times 2 times g, which is ln x, plus g is 1 over x, and times e to the power of 2x. You just factor out e to the power of 2x, and you write the rest of it, and you're done. What about this one? A log, flip it over by the chain rule multiplied by the derivative of this piece, which is 2x. So it's just here next to that. And because the base is not e, so 1 over f of x, f prime of x, 1 over ln b, 1 over ln 5, and put them all together. And this is the final answer. What about this one? First, we use the quotient rule. So ln of 2x minus ln of 2x plus 1. Because if we don't, everybody, if we don't, we have to flip this over and then multiply by its derivative, which uses the quotient rule. So it takes longer. ln 2x, now we use the product rule, is ln 2 plus ln x. Because ln 2 is a number, the derivative is 0, ln x is 1 over x. This one, flip it over, so minus 1 over 2x plus 1, and then times 2 by the chain rule. Obviously, x times 2x plus 1 is the common denominator. Now, this is it. This is the only calculus step. 1 times 2x plus 1 minus 2 times x, and 2x plus 1 minus 2x. These two cancel each other, and we are done. We want to find an equation of a tangent line. We need a pair and the slope. To find the slope, we differentiate. We get 2x minus 3. And if we plug in 4, we get 5. And that's the derivative. And that's the slope. Okay. Please understand, f prime is not the slope. It represents infinitely many different slopes. Plug in becomes a slope. And now, what about the pair? If you plug in the 4 back into the original function, that gives you the pair 4 comma 3. And so we can use the point slope. We plug in. And we get y equals 5x minus 70. Bear in mind, the pair belongs to the function, also to the tangent line. Okay, so it should work for both of them. A doctor prescribes a 300 milligram drug to be taken every 12 hours. Just before each tablet is taken, 40% of the previous amount of the drug remains in the body. 12 hours, very important, does not enter any calculations here. So we want to answer that. And the very first thing is to write the given. The only thing you want to pay attention, we are dealing with Q instead of B. So B sub 0, we're going to write Q sub 0 or A 0 because we're dealing with patients. And lowercase c is the amount of constant the patient receives on a time step. Time step happened to be 12 hours, so it's 300 milligrams. And what remains in the body is important, so R is 0.4. And therefore, if we want to answer this one, we're going to write this one and change it to Q. Now use the given, replace the R with 0.4, C with 300, and you're done. Same thing for this one. We are going to use this formula and B becomes Q. And again, we go back to the given to make life easy, plug it in. 0 makes this one 0. This is 0.6. We put it under 300, which is 3,000 over 6, and therefore 500. Because we want in part C the fifth, the effect of the fifth one, we replace the n with 5. We put it into a calculator. Gives us 494.88 milligrams. So how much drug is left after the fifth tablet? 494.88 milligrams. What about the limiting value? You take a limit, and since this number is between -1 and 1, as n goes to infinity, this goes to 0. The answer is 500 milligrams. So what does it mean? According to this, and according to this time step, it will never go over beyond 500 milligrams, and they have calculated that would be safe for the patient. F of x is given, we want to differentiate. When we are looking at the exponential, the derivative and the integral are the same, except in the case of differentiation, we multiply by -0.2, and integration we divide by it. So 4 times -0.2 e to the power of -0.2x minus the derivative of sine is cosine. We put these two together, we get -0.8 e to the power minus 0.2x minus cosine x. To integrate that, you have to put a dx next to it. And again, as I mentioned, the answer is itself, but this time we divide by -0.2. Sine, the derivative is cosine, but the integral is minus cosine, with this minus makes it plus, and this is 40 over -2, which makes it -20, and that's the final answer. What if f of 0 equal 20? That means go with the initial value problem. And that means this is a general solution, everybody. Now there is a pair. So replace the x with 0, f of x with 20, and you find the missing constant, in which case this is 1, so we get minus 20. Cosine of 0 is 1, and I hope you see that c ends up being 39. Plug it in, you're looking at a particular solution. So with the help of one pair, the indefinite integral, which is a family of function, becomes 1, which is a function. We want to integrate this. We are going to change this into x to the power of 1/2, and we make up two fractions. This has exponent 1, 1 minus 1/2, and now we are ready for integration. This one is 1 over 1/2 x to the power of 1/2 plus 1. This one is 1 over -1/2 plus 1 x to the power of -1/2 plus 1, and a constant, we are using the power rule. 1/2 and 1 is 3/2, -1/2 and 1 is 1/2. The 1 over 3 halves, that means the reciprocal of 3 halves, 2/3. This one is 2, and we are done. When you want to integrate this, you use the u substitution. U substitution means first you have to write the u, then du dx, and then du. Now, whether you write du dx, it's not important, but you have to write u and du. And the tip is look for a function u equals g of x and its integrand, and du or g prime of x by dx in the integrand anywhere. When we have polynomials, the more complicated one, in this case, x squared plus 5 is the choice of u, which makes du dx to x. If you don't want to write this, you don't have to, but you must write this to u and du. I'm going to move the 2x so it becomes clear. This is u, this is du, so you have the integral of u to the power of 30 du, and that is a simple case of a power rule here. 1 over 31, u to the power of 31 and a constant. Reverse process gives us 1 over 31, x squared plus 5 to the power of 31 plus c. As always, differentiating the result will prove we haven't made a mistake, because if you differentiate it, you get the same thing without the dx. When you have a fractional expression such as this one, or a rational expression such as this one, the first step is simplification. When you can't, the denominator is a choice of u. Notice its derivative is the numerator, which makes the u e to the power of t dt. I'm going to put the dt at top because I want the reader to see I have a du over u, and that is a simple case of a log. Therefore, the natural log is the answer and a constant. And replace the u, natural log of 5 plus e to the power of t plus a constant. And of course, if you know this expression is positive, you can, and you should know it, so you can get rid of the absolute value. In this case, you can simplify. The choice of u would be the denominator x squared plus 2x minus 1. I've explained that, you can calculate b squared minus 4ac here. And that if it's a perfect square, it can be factored, but it's not, and it cannot be. The derivative is 2x plus 2, or 2 times x plus 1, which makes du 2 times x plus 1 dx. When we put the dx next to the numerator, it becomes clear that everything is in order except 2 is missing. As I mentioned in most texts, they solve for dx. We don't have to. You just throw in 2 and 1/2. And so this is a simple case of a log as a result, and plug in and you're done. What happens if you have a reciprocal of any of those? For example, if you have a reciprocal of this, you make up two fractions, this one and this one, and you no longer need to use the substitution. This becomes 5 e to the power minus t divided by -1 or minus 5 e to the power of -t. This becomes t and a constant, and you're done. What happens, we have ln x, always ln x is a choice of u. As you know, its derivative is 1 over x, therefore du is 1 over x dx, or dx over x. There are different formats, but they both mean the same thing. We are going to separate this into two pieces such that it becomes clear this is your du, everybody. This is truly helpful. So you have u squared times du. A simple case of a power rule results in 1/3 u cubed and a constant, and now you replace it. Needless to say, this is not the same as ln of x cubed, two different things. For part B, notice the denominator. If you take the derivative, you get the numerator, so you let the bottom represent the u, and the top times dx is therefore du, you put the dx next to it. So in the integral of du over u, that's a natural log. And again, if you lose the absolute value because this expression is positive, that's fine. again, it's up to you. Pay attention that theta is the independent variable, so 5 gives you 5 theta. Plus 2 cosine theta gives you plus 2 sine theta plus a constant. Very simple. The derivative of cosine is negative, but the integral of cosine is positive sine theta. What about this case? Anytime you have exponential, the exponent is the choice of u. Its derivative, 5x to the power of 4, therefore du, 5x to the power of 4 dx. We move things around, so we can clearly see that everything is in order except number 5. You can solve for dx, or better yet, just throw in the 5, undo it with 1/5. And so the answer is just e to the power of u. Don't forget the 1/5 and a constant. Replace the u with x to the power of 5 minus 2, and you're done. What about this one? Natural log is the choice of u. Its derivative is 1 over x plus 1 times 1. So du is 1 over x plus 1 times dx. So now we are again rewriting this to make sure the reader can see that you're dealing with u du. What are the limits? Well, not the original limits. So what are the limits? You plug in 0, you get ln 1, which is 0. But if you plug in 1, you get ln of 2, and those are the limits. Okay, everybody? Now, when you plug in 0, it doesn't do anything. So just the top, and this is the exact answer. The bottom gives you 0, has no bearing. Always keep it as an exact answer, half of ln2 quantity squared. What happens here? I want to discuss sinusoidal functions. What happens when the argument has an exponent? That's a choice option. As you know, its derivative is 2x. So du is 2x dx. Move the x, so it becomes clear that this one is fine, except number 2 is missing. Instead of solving for dx, I'm going to put the 2 and undo it with its reciprocal because it's a number. And sine, the derivative is cosine, the integral is negative, so it's minus 1/2 cosine u and a constant, and replace it, and you're done. Whenever you have sine and cosine, the one with the exponent is the choice of u. Of course, no exponent. The derivative of u equals sine x is cosine x, so du is cosine x du. So basically you have u squared and du here. 1/3 u cubed, replace it, you're done. Very straightforward, everybody. We've seen this a number of times. What if we have cosine and sine, and cosine has the exponent? Well, u is cosine. Its derivative is minus sine, therefore du is minus sine x dx. So we rewrite it in the following manner. I'm going to put negative inside and negative outside. Their product is positive 1. We are fine. So we are looking at minus the integral of u to the power of 20 du. So the answer is minus 1 over 21 u to the power of 21 and a constant, and replace the u, and you're done. So very straightforward, everybody. Many fish grow in a way that is described by von Bertalanffy growth equation. For a fish that starts life with a length of 1 centimeter and a maximum length of 30 centimeters, this equation predicts that the growth rate is 29 e to the power minus x centimeters per year. where X is the age of the fish. How long will the fish be after 4 years? And they want one decimal. There are a couple of ways to do that. First and foremost, if capital L represents the length of the fish, then its growth rate, its derivative, L prime or dl dx is this one. And the initial value is 1. So there, the amount of increase would follow the accumulated change formula. So from 0 to 4. The derivative and the integral of exponential is itself, you just divide by -1 here, and you plug in 4 and 0. You have to put it into a calculator. You come up with the answer, and consider L of 0 is 1. So it's the sum of the two. And because we want to go with one decimal, 4 next to the 6 goes to 5. And that's very straightforward, everybody. Okay, that's very straightforward. What I want to do, I want to look at a different point of view in case. Okay, and I want to find capital L of x, which is the integral of this. And since we already have the answer here, just this thing plus a constant, and the initial value is 1. So this is general formula. This is the family of function. With this 1 point, we can find a specific solution. L of 0 gives us c equals 30. That's a specific question. That's one formula, one function instead of family of functions. After 4 years, replace the x with 4. And as I've mentioned it many times before, the advantage of this is if somebody says, okay, how long is the fish after 5 years, 6 years, 7 years, 2 years, you just have to replace it. It's that simple. Okay, instead of having to go through this process of integration here again and again. So that makes it easier. The distance in meters of an object from a starting point is given by s of t, where t is time in seconds. What is the velocity of the object from 2 to 4 seconds? And I hope you remember we're talking about the average velocity. That means total distance, s of t2 minus s of t1, over total time, t2 minus t1. So s of 4 minus s of 2 over 4 minus 2. That's elementary algebra. So you plug in 4, you plug in 2, you calculate, and you have the answer. This ends up being 52. This ends up being 38. Their difference divided by 2 is 7 meters per second. So this is elementary algebra, everybody. We're not going to worry about that too much, okay? Now, the instantaneous velocity and acceleration, basically the velocity is just a derivative function. So it becomes 4t minus 5. And after 6 seconds, you plug in 6. You get 19 meters per second. Acceleration is the second derivative. That means differentiated again, you get 4. Acceleration is the second derivative. And you get 4, which happen to be a constant. You have to plug in, and the units is meters per second, as I had explained that before. So A of t is dv dt. That's why the change in velocity over change in time, meters per square second. When does the object reach a velocity of 31 meters per second? So replace this 40 minus 5, set it equal to 31. And move this, make it plus 5. 36 divided by 4 is 9 seconds. So very straightforward, everybody. want to use differentials to approximate this. So what do we need? First and foremost, what type of a function? Just read it. Cube root of something. So cube root of x. The next thing is you need the number closest to 63.5 that you know the cube root. Obviously, the answer is 64 because cube root of 64, we should know it's 4. Okay. And so dx or delta x is the difference between the 263.5 minus 64 is minus 0.5. Please understand why negative. We know the 64 and we want to go to a smaller number, so the answer will be less than 4. But if we were to go to 65, I want to make sure we understand that if the question was, okay, what about square root of 65? Dx is positive 1. Okay, 65 minus 64. So we are going to write f of x plus delta is f of x plus dy. We have f of x, we need dy, so let's find the derivative first. So we write it x to the power 1/3. Its derivative is 1/3 x to the power minus 2/3. Or we can write it in this format, which makes dy the same thing times dx. Same thing times dx. So now we put f of x, this function, and dy this function. We want cube root of 63.5. That means we want f of 63.5. That means f of 64 plus negative 0.5, which means replace the x, replace the dx. And when we do that, this becomes 4. This becomes 4. Square root 16 times 3 is 48. And I hope you see that this is 1 over 96. So 4 minus 1 over 96 is 3, and 95, 96. And this is with the approximation using it. Let me erase my work with the calculator. As you can see, they are very close. This is the calculator work. This is fine. And if I was going to stop at 4, this becomes 6, the same thing. The reason they are very close because 0.5, the x is very small compared to the choice of x. So with that being the case, we want, and we're done. We are going to look at L of x as well, which is known as linearization, using the point slope formula. So what is L of x? Well, you need a pair. Well, if you plug in 64, you get 4. You need the slope. If you plug it into the f prime of x, so plug it into this, you get the slope. This becomes 4 times 4 squared. 16 times 3 becomes 1 over 48, and this becomes 64 comma. So I hope you see what's happening. So y minus y1, that means y minus 4 equals n1 over 48 x minus 64. And now all you have to do, just 1 over 48 times x minus 64 over 48 and move the negative 4. Simplification will give you this one. And if you plug in 63.5, it must give you the same answer, and it does. Okay, everybody? Again, very straightforward. Find the absolute max and mean value of the function where f of x is given, and here's the closing interval. First and foremost, I want to remind you, what's a polynomial function? F of x in the form of a sub n x to the power of n all the way to a sub 0 is a polynomial, where a sub n can't be 0, and n all the way to all those exponents must be whole numbers 0, 1, 2 to infinity. Domain is always all real numbers. This is a polynomial of degree 4, which makes it continuous from negative to positive infinity. When we say domain, it means it's continuous. Therefore, it makes it continuous in the given interval of negative 4 to. And so what do? We can move on with this method. We are going to find critical points. To do that, we need f prime of x. So that's 4x cubed minus 36x. and we are going to set it equal to 0. That means we are going to factor out the 4x. This is x plus 3x minus 3. And now there are three answers. X is 0, x is negative 3, x equals 3 if we set this equal to 0. F prime doesn't exist. That doesn't produce any solution. Remember, phi represents an empty set. The reason it doesn't, because f prime itself is a polynomial of degree 3. So there are three answers. We check the given interval. 0 is in between. Yes. Negative 3 is in between. Yes. Positive 3, no. Positive 3 is larger than 1. It's outside, so we can't use that. So we evaluate the function at the endpoints on these two. So that means you just plug in. And so minus 4 to the power of 4 is really 16 times 16. This is minus 18 times 16. So it gives you minus 32. For negative 3, you get negative 3 to the power of 4. Minus 18 times negative 3. And if you work it out, you end up with minus 81. 0 gives you 0. And 1 gives you 1 to the power of 4 minus 18 times 1 to the power of 2, which gives you 1 minus 18 or minus 70. And so the largest, all of them are negative. So the largest number is this, and the smallest number is this. And we're going to say absolute max is 0 at 0, 0. Absolute is minus 81 at negative 3, negative 81. That's how we do that. What about evaluation of this integration? And so again, you have polynomials. 25 minus x squared is more complicated. Choice of u. Its derivative is negative 2x. That makes du negative 2x dx. And so we are going to move things around. We put the negative 2 and undo it. We rewrite it. And I'm not writing the limits yet because the limits are different. And we know how to integrate this 1 over 1/2 plus 1, u to the power 1/2 plus 1. This negative 1/2 doesn't go away. And so the product class, this is, remember, 3/2. This is 2/3. And the product of these two is negative 1/3. And we can go back to original variable and original limits. Or we can put the 3 here, it becomes 9. 25 minus 9 is 16. Or we can put the 4, we get 16. 25 minus 16 equals 9, and use those limits. We plug it in, and we end up with the following. Now, to evaluate 9 to the power of 3/2 means square root of 9, which is 3, cube it, becomes 27 minus square root of 16 is 4, cube it 64. The difference is negative 37. We get 37/3. The radius of a blood vessel is 1.4 millimeters. A drug causes the radius to change to 1.3 millimeters. Use differentials to find the approximate change in the area. So we have a circle, okay, and it shrinks. So originally this is the radius, and the new one is this, and the difference is dr. First, understanding the concept. So what is given is that r is 1.4. And dr is the difference between the two, which becomes negative 0.1. And of course, a is pi r squared. We want to find dA. This is the approximation of the shaded region. Since f prime of x is dy dx, a prime of r is dA dr. Just, I want you to compare and contrast. Therefore, dA is the product of these two. So if a is pi r squared, let's find dA dr, and dA dr starts with pi, and then times r squared gives us 2r, or 2 pi r, which makes dA 2 pi r times dr. And now we just plug in. R is 1.4 and dr is negative 0.1. Again, exact, negative 0.28 pi millimeters squared, roughly. Now, it's important to understand we can actually find the exact answer, which is delta A. Delta A is the area of the two circles and subtract one from the other. So this one is the smaller one, pi r squared, or pi 1.3 squared. The bigger one, pi r squared, or pi times 1.4 squared. I factored out the pi, and as you can see, these two numbers are very close. So you can find the exact answer, but they wanted approximation. A farmer with 240 feet of fencing wants to build an E-shaped enclosure besides a creek, as seen in the diagram. Find the maximum area that can be enclosed. So define your variables. Here's x, here's y. So you want to maximize the area, which is x times y. Now, we have 240 feet of fencing. We have 1, 2, 3x, and normally we have 2y, but in this case, only 1y. Okay, so just we want to pay attention to what's given. You solve for y. The reason why, because you want a function of x by putting it in. And x is a dimension, must be positive, and it's less than 80, because if you set this one equal to 0, x becomes 80. So if you choose x to be larger than 80, this becomes negative, and you can't have a negative sign. Now, differentiation will result in 240 minus 6x. Because we are looking for critical point, we find that we set it equal to 0, x becomes 40. We have an open interval of 0 to 80 with one critical point. So that is not only local, it's also absolute. So the best course of action, A double prime, is simply negative 6. And negative means concave down, maximum at x equals 40. So if x equals 40, 3 times that, 120 subtracted from 240 gives you 120, and the area is 4,800 square feet. So that's very simple. You have to go back to the original one and figure things out. We've seen this concept many times before. Fractional expression, the first step is to simplify if you can. You factor the denominator into 2x plus 3 times x minus 1, but it doesn't change the fact that it can't, the numerator can't be factored. So the denominator is a choice of you. Its derivative is 4x plus 1, which makes du the same thing times dx. You put the dx next to the numerator, becomes du over u. The answer is a natural log. Replace it, you're done. But this one, we can factor the numerator as well, which means we can get rid of x minus 1. And you must always work with the simplified version of a fraction. So notice, again, the denominator is a choice of u. The derivative is 2, and therefore du is 2 dx. And if you look at these two, you have four of them, so you can make it 2 times 2 dx. It's not a big deal. So the 2 remains. This one is du over u, and the answer is 2 natural log and a constant. Replace the u and you're done. Now, if I look at the reciprocal of this, then I get the reciprocal of that because it can, factor the x minus 1 out again. And this gives us 1/2 x. This gives us 3/4. This gives us half of x squared, with this becomes 1/4 x squared. This is 3/4 x and a c. The point being substitution, substitution, no need for that. And so you want to distinguish between the two. When do we need it and when not? A bacterial colony has a population of P of t equals 22 over 10 plus t squared in millions t hours after nutrient is introduced. Use differentials to approximate the change from 2 to 2.4. Well, t is 2. dt or delta t is the difference between the two, which makes it 0.4. And we want to approximate the change, that means dp. And so if p of t is this, p prime is dp dt, and dp is the product of these two, which means first and foremost, differentiate this using the quotient rule, and let's call it f over g. So differentiate the top, you get 20 times the bottom, which is 10 plus t squared, minus differentiate the bottom, which is 2t times the top, which is 20t, and then write the bottom, square it. You have to simplify this. (200 plus 20t squared minus 40t squared. This is it, which makes dp this one times dt. Plug in, put it into a calculator, 0.245 or 245,000. That's the number. The exact number is just plug in 2.4, subtract, so p of 2.4 minus 2 of p of 2. So into this function, plug in 2.4 and 2, that's the exact answer, which is 189,000. So it's doable to find that, okay, class? And I want you to understand the difference between delta p and dp. If g of x is continuous at x equals minus t, why or not? Why not? G of x is a piecewise defined function. Each piece is a linear function, and the entire domain of negative to positive infinity is defined. So we use the one-sided limit. A limit exists if the limit of f of x as x approaches a equals f of a. So the one-sided limit, first we start with the functional value. The functional value uses the equality. And when we plug in -2, we get -3. The left side uses the less than. And if we plug in -2 into that, we get -1, and 3 is +2. For the right side limit, we use the greater than, so x minus 1, and if we plug in, we get -3. Again, one-sided limits, a function has a limit if and only if limit of f of x as x approaches a from the left and a from the right are the same, and the same as the functional value. Obviously, limit does not exist, and because the limit does not exist, the function is discontinuous at x equals -2. I hope you recognize that because these two are equal, that means the functional value and the right side limit, then say g of x is continuous at x equals -2 from the right. Yes, that's true because these two are the same. These two are the same. That's why that's the terminology, everybody. All right, we are interested in the limit of g of x as x approaches 2. That's why we look at the left-sided limits from the left side. We are here moving towards this point. and this point has y coordinate 3. From the right side, we're moving here. The answer is 1. The limit doesn't exist because they are not identical. What about number 5? From the left, we are moving this way. From the right, we are moving this way. And I hope you see in both cases, we are moving towards there. We never get there, but we have the answer. In all cases is 2. Limit from the left, limit from the right, therefore it exists. Okay. If we assume this is 1.4, that means g of 5 is 1.4, which is not equal to the limit. So it's a discontinuous function. However, we can fix it. So this is the definition of a continuity. G of x can be continuous at x equals 5 if redefine g of 5 to be its limit. Okay, so this can be fixed. But what about this one? It's a jump. There's nothing we can do to fix it. G of 2 is undefined, but that's not the problem. It's a jump. Can't be fixed. All right, so we are interested in finding the limit of R of x as x approaches 2 from the left and right. I hope you see it goes to negative infinity. Left and right for 5 goes to positive infinity. Negative 3 from the left of it is negative infinity. From the right of it is positive infinity. And that's the definition of a VA. As you know, VA, the limit of f of x when x approaches a, or a from the left or a from the right, is positive or negative infinity. X equals a is the vertical asymptote. So the vertical asymptotes have equations x equals 2, 5, x equals negative 3. So that comes with the definition, everybody.